Hi guys, this is Algebra Lesson 8.6, and the book calls this solving x squared plus bx plus c equals 0. I would call this factoring into binomials, or I might call this unfoiling. We're going to get to the solving part at the very end of the lesson, but we're going to talk about the actual factoring skills first. So we're talking about factoring something that looks like x squared. We will call this ax squared plus bx plus c. A is going to be a 1 all the time today. B can be a number, negative or positive, and C can be a number, negative or positive. One thing you can remember about these equations when we're looking at the C number, that is going to be the y-intercept on the graph. I'll show you that in just a little bit. Okay, let's work an example and do this unfoiling thing. The first example I'm going to show you has all positives, x squared plus 9x plus 20. And what we're going to do is we're looking to factor this into a pair of binomials just like this. And because we have a 1 that starts this, our very first terms are just going to be x times x, because when I FOIL this and I do the first, I will do x times x is x squared. To get the rest of it, what we're going to do is we're going to start by looking at this number right here, this 20. We are going to look at factors of 20. We could do 1 times 20. We could do 2 times 10. 3 doesn't go into 20, but 4 does. And 5 times 4 is 20. Now, here's a little hint. Whenever you get to something that repeats backwards, the last thing you just did, you can know that you are finished factoring. We don't really need to repeat ourselves. All right, positive times positive multiplies to be positive, and positive adds to be positive. That's important because now we're going to look at this positive 9. The next step is to look at our factors and see if there are two numbers that add together to make 9. And I see that there are. There's a 4 and a 5. So I'm going to use, that 4 and put it here, and that 5 and put it here. Actually, the order doesn't matter, but I am going to test myself by doing FOIL. Okay, I'm going to go first. X times x is x squared. Oops. Let's just go here, outer, x times 5 gives me 5x, inner, 4 times x gives me 4x, and last, 4 times 5 gives me 20, and we can see that when we combine the outer and the inner here, I come back to my original trinomial. So what's true here is that x plus 4 times x plus 5 is the same thing as x squared plus 9x plus 20. One of them is in factored form and the other is in expanded form. All right, example number 2 looks like this. X squared minus 8x plus 12. Notice that we've thrown in a negative. So we're going to do the same thing. We're going to first look right here at this 12, and we are going to come up with the factors of 12. 1 times 12, 2 times 6, 3 times 4, and then when I get to 4 times 3, I'm repeating myself. Now, a positive times a positive gives me a positive, but also a negative times a negative gives me a positive. And this time, when I add my numbers together, I need them to equal -8. So, positive and a positive are not going to equal a -8. So I am going to switch to the negative times the negative. I'm going to make both of my factors negative this time. because when I multiply negative times negative, I'm still going to get positive 12, but when I add them together, I can find something that adds together to make negative 8. In this case, negative 2 and negative 6. X minus 2 times x minus 6. Again, we can FOIL to check our answer. X times x is x squared. X times negative 6 is minus 6x. Negative 2 times x is minus 2x. And last, negative 2 times negative 6 is going to give me that positive 12. When I combine my outer and my inner, I am going to be back where I started from. All right, that's the second example. Sometimes our negatives are going to look more like this. X squared plus 2x minus 15. So in this case, we have minus c. 15 is our c number here. So when we factor, we need to come up with numbers that multiply together to make negative 15. We know that I'm going to need a negative and a positive. All right, to be strategic, we're going to come over here and look ahead just a little bit. When I add them together, they're going to make a positive 2. So that means that these numbers, the positive and the negative, one of them, the bigger number, can be positive and the smaller number can be negative. Let's go ahead and get those factors first, and then we'll put that together. 1 times 15, 2 doesn't go into 15, but 3 does. And then we would say 5 times 3, and I'd be repeating myself. Okay, in this case, I'm going to make a negative 1 and a negative 3 because those are the smaller numbers. The bigger numbers being positive are going to allow me to think about getting positive 2. So that could happen if I had a negative 3 and a positive 5. So the factors I want are x minus 3 times x plus 5. And again, I can check myself. X times x is x squared. X times 5 is 5x. Negative 3 times x is minus 3x. And negative 3 times positive 5 gives me a negative 15. I'm going to put these outer and inner terms together to get plus 2x minus 15, and that checks out. All right, we'll do one more that has some negatives involved. We're going to have x squared minus 7x minus 18. And when I start with my negative 18, I know I need a positive and a negative. Let's go ahead and just get those factors. 1, 18, 2 and 9, 3 and 6. 4 doesn't go in there. 5 doesn't go in there. We're back to 6 times 3. And I know I need one set of numbers to be positive and one set to be negative, but this time when I add them, I want them to be negative. So I'm going to make the bigger numbers all negative. So negative times positive, we'll get back to the negative 18, but when I add these, two of them could make a negative 7. So I think that would be right here. And I'm going to factor like this: x plus 2 and x minus 9. We can look at FOIL to see if that worked. X squared, x times negative 9 gives me minus 9x. 2 times x gives me plus 2x. And 2 times negative 9 gives me negative 18. Combining my outer and inner, I am going to get x squared minus 7x minus 18, and we're back where we started from. So we know we are correct. All right, so what's a useful application for this kind of factoring? There are lots of uses for it, but one that we're going to talk about today is solving an equation. If I have something like x squared plus 6x equals 27, I can use my factoring to actually solve this. Whenever I have x squared and x in the same equation, this causes problems for solving. We have to use special techniques, because we can't simultaneously solve for x squared and x. We can't combine them, and we can't figure them out. So we have to use some tricky things. In this case, we are going to try to use our factoring. All right, we want this to equal 0. We covered this in the last lesson. If we have two things or more multiplied together to make 0, we know that at least one of them has to be 0. And in the case of something that starts with x squared, we're looking for two answers anyway. So it's going to be fine that we have two factors and make them each equal 0. All right, so in order to make this equal 0, I'm going to subtract 27 from both sides. 27 doesn't fit in with any of our other terms, so we're just going to write it like this. And that's the same thing, just rearranged a bit. And then we want to try to factor this into our two binomials. So we're going to start by looking at negative 27. Okay, negative 27 can be factored into 1 and 27, not 2, but 3 and 9, not 4, not 5, not 6, not 7, not 8, but 9 and 3, and I'm repeating myself. Okay, I need a positive and a negative in order to make a negative. And in this case, I'm looking at plus 6 for an answer when I add them. So I'm going to keep my bigger numbers positive this time so that when I add them, it'll stay positive. And I notice that negative 3 and positive 9 will give me the positive 6 I'm looking for. Okay, so let's go x minus 3 and x plus 9. If I went and used FOIL, I could check myself here. That would be a smart thing to do. I'm going to move on and show you how I'm going to set each little piece here equal to 0. It makes two little mini equations because I have this times this, and each piece could equal 0 in order to get 0 as my answer. So I'm solving this, and I get x equals 3. I'm solving this. I get x equals negative 9. All right, what does this mean? I have two answers, right? Well, this is the reason why we're looking at this. If I have a graph, anything that starts with an x squared like that is either going to be a smiley face, call it a parabola, or a frowny face, also called a parabola. In this case, since I only am dealing right now with factoring things with positive numbers, let's call that A. It's the number in the front. When that's positive, we are always going to smile. If A is positive, we're going to be smiling. All right, so if x equals 3, let's say that's right there. And if x equals negative 9, and that's right there, what's happening is our parabola, our smile, is actually going to cross through those two places. Those are the x-intercepts. We call them, here, let's just write that. These are the answers. We also call those solutions. We can call these x-intercepts. We call them zeros, partly because we solved it to equal 0, and partly because right here, y equals 0 right on the x-axis, and the other word that we call these is roots. All of these words mean the same thing. All right, so here's our parabola. It's going to be a smile, and the other little piece that we can know is right here, that's our y-intercept. That c number, that constant that doesn't come with a variable, it's at the very end. I'm not going to make this to scale, but let's say negative 27 is way down there. My parabola is going to look something like this. It's hard to draw these so that they look decent, but we're dealing with a graph that looks something like that. We're going to begin talking about things that make this kind of graph. Anything with gravity, anything with balls, frisbees, footballs, anything that jumps, horses that jump, dogs that jump in agility, anything with rockets, anything with guns and bullets. All of these things make this kind of a graph, either going like this, lots of them go like this, or like this. Things that deal with gravity and area, lots of things that you will see in science. Pretty cool. I'm not going to do a lot of practice problems with this today and make this video longer. I'm going to make this available to you, but everyone was in class. You can find more practice problems on page, let's see, I'm looking at 507 is where the practice is of your textbook. The odd answers are in the back of the book, so you could always work those. And you're going to do plenty of practice in your ALEX. Let me know, send me topics when you run into things that are difficult, and I'd be happy to help. And I will talk to you later.